Usually when we think about the passage of time, we just sort of visualize it as a clock on the wall.
Yeah, a purely mechanical thing.
Exactly. Like it's just this objective measurement. You watch the second hand sweep around, and it's just, a neutral, uninterrupted progression of math.
Right, the universe is just ticking forward. It's completely indifferent to what actually happens within it.
Yeah, and that's fine until reality hits, like the moment you look in the mirror. Or, when you feel that persistent ache in a joint that, used to just heal overnight when you were younger.
That's when it gets real. Time suddenly loses all that neutrality.
It really does. It becomes profoundly personal and intimately biological. You just can't deny it anymore.
And that specific intersection is where the human experience becomes, well, remarkably complicated. Because we're forced to confront this reality, the objective clock on the wall and the subjective biological clock ticking inside our own cellular machinery.
They operate on totally different paradigms.
Completely different.
Because our minds, right, like our sense of self, our memories, our personality, they don't age in parallel with our physical structure.
No, not at all. You ask anyone, they often say they still feel 25 inside.
Right. There's this relentless, almost like defiant expectation of continuity built into our consciousness. We genuinely feel like we are meant to live forever, even while we're actively watching the breakdown of our own physical scaffolding.
It's the defining paradox of human existence, really. Our minds are just constantly fighting for continuity, while our biology insists on a hard finality.
Exactly. And that tension, it's basically birth philosophy-driven scientific innovation, anchored religious thought since, the dawn of human consciousness.
Because it forces us to ask a really tough question. Why would a biological machine, which is literally programmed to expire, be equipped with a consciousness that can even conceptualize, let alone desire, eternity?
Which perfectly sets the stage for today's deep dive.
Yeah.
We're jumping into a truly compelling text today. It's Chapter 9 of Analyses Biblico-Scientificas by Ozair da Silva Mota.
Yeah, this is a fascinating one.
It is, and our mission today is to analyze the inevitability of aging and death through a very deliberate dual lens. We're going to seamlessly blend a rigorous scientific approach.
Right, getting into the actual microscopic chemistry and genetics.
Exactly. We're blending that cellular degradation stuff with a profound biblical and theological approach.
Because to really get a comprehensive understanding, we can't just catalog the biological mechanisms. We will certainly look at the devastating effects of free radicals and, DNA mutations and the hard limits of cellular division.
Oh, absolutely.
But we have to simultaneously interrogate the why. The text really demands that we unpack the theological implications of things like free will, the dangers of fatalism, and what the original intended design of human life actually was.
So we're essentially placing the biological mechanics right side by side with the spiritual purpose.
That's the goal.
Okay, so the text kicks off this dual approach by laying down a foundational theological premise based on the Genesis account. And it highlights a really vital nuance regarding the sequence of creation.
Right. The timeline is key here.
Yeah, the entire physical ecosystem, right? The cosmos, the planet, the flora, the fauna, all of it was meticulously prepared and balanced prior to the introduction of humanity. Humanity was positioned as the crown of this material creation, placed into an already finalized environment.
And the linguistic distinction the author draws there is crucial because, according to the biblical record, humans were not merely created in the broad sense used for the rest of the physical world.
What do you mean by that?
Well, the Hebrew concept translated there implies being formed. It evokes this imagery of a craftsman.
Oh, interesting.
Yeah, it denotes a differentiated, intimate level of care. It suggests a direct resemblance to the Creator. Because humans were the final, culminating act, it indicates that the environmental parameters required for their survival and flourishing were, already perfectly calibrated.
Okay, that makes sense. And the text uses this really fascinating reflection on modern behavior to illustrate how deeply this concept of being a formed spiritual entity is just embedded in our psyche.
The funeral analogy, right?
Yes. Think about the language we universally use around death. When you go to a funeral, you don't tell someone you're going to see the person.
No, you say you're going to view the body.
Exactly. The semantic choice is so revealing. It exposes this philosophical truth that humanity just subconsciously acknowledges, regardless of culture.
We instantly recognize that the essence of the individual, the consciousness, the personality, the spirit, it's vacated the premises. The true individual is no longer present.
What remains is merely the biological housing. The text actually refers to it as the tabernacle, which really emphasizes its temporary nature.
So this establishes humans as spiritual beings temporarily utilizing a biological interface to interact with the material dimension.
Which leads to a really big question that the text brings to the surface. If humanity was originally designed for this unbroken communion with a creator, is our visceral survival instinct, like that deep psychological resistance to our own mortality?
Is it actually a remnant of immortality software?
Yes. Are we basically running infinite loop software on hardware that was subjected to degradation?
Framing it as an incompatibility between software and hardware captures the theological argument perfectly, because the human spirit and conscience are characterized as entities that are inherently oriented toward infinite continuity.
They're structurally opposed to stopping.
Exactly. The physical body, however, became subject to a radically different biological reality. And to explain the origin of this degradation, the text centers on Romans 5.12, noting that sin entered the world and death through sin.
Right, so in this framework, death is categorized strictly as an intruder. It was literally never part of the original design specification.
The intention was eternal communion. So death, and specifically premature or violent death, is a catastrophic disruption of that ideal state.
It's a complete interruption of the intended trajectory. But the text does introduce an important nuance here about the physical body in the post-Eden reality.
Right, because it notes that the biblical ideal for human life, even in this fallen, degrading state, is a blessed old age.
Yeah, we see this repeatedly with the patriarchs. Figures like Abraham, Isaac, Jacob, they're described as dying full of days.
Which means the ideal is not a life abruptly truncated by disease or trauma. It's a prolonged, complete narrative arc where the individual fulfills their purpose before the biological machinery just naturally winds down.
So if sudden death is the ultimate intruder, the slow, unavoidable process of aging is its footprint. It's the intruder just methodically working its way through our biology.
That's a great way to picture it.
So we need to understand the mechanics of that footprint. How do we transition from this remarkably resilient, self-healing biological system in our youth to a system that inevitably fails?
Well, to map that deterioration, the text shifts into a really rigorous scientific analysis. We have to bypass the macrostructures, the organs and tissues, and examine the foundational chemistry of life.
We're going down to the atomic level.
Exactly. The core driver of aging originates at the atomic level, driven by the fundamental pursuit of energetic stability.
Okay, so we all know oxygen is vital for cellular respiration.
Yeah.
But the text points out the dark side of that process. An oxygen molecule is perfectly stable when its electrons are paired, right?
Right. But biological processes, particularly the generation of energy in our mitochondria, they're messy.
Very messy.
So sometimes an oxygen molecule loses an electron and becomes a superoxide anion. It goes from being a stable element of life to a highly reactive free radical.
And because that free radical is missing an electron, the laws of chemistry dictate that it has to find a replacement to regain stability, right?
Yeah, it basically becomes a microscopic agent of chaos. It aggressively strips an electron from the nearest available molecular structure, whether that's a protein, a lipid in a cell membrane, or even a strand of DNA.
Which triggers this devastating cascade. The molecule that just had its electron stolen is now unbalanced itself. So it becomes a free radical forced to steal an electron from its neighbor.
It's a total domino effect of molecular theft.
And this process is known as oxidative stress. For those listening, you can visualize it as a biological version of rust. In the same way that oxygen reacts with iron, slowly degrading the structural integrity of a car until it just flakes away, these free radicals are methodically rusting our cellular infrastructure from the inside out.
And that continuous microscopic rusting forces the body into a perpetual state of emergency triage. The cellular damage has to be constantly repaired, which forces the body to accelerate cellular regeneration just to maintain basic function.
Right.
But when cells are compelled to replicate rapidly and under the duress of continuous oxidative damage, the structural integrity of the tissue begins to fail.
And that leads to major problems.
Oh, massive problems. This is a primary driver of premature aging and a huge catalyst for oncogenesis or cancer because that accelerated replication increases the likelihood of severe genetic mutations.
So the natural question for anyone listening to this is, how do we slow down the rusting process?
Right. How do we stop it?
Yeah. And the text makes it very clear that while our basic metabolism produces free radicals naturally, the volume that actually causes rapid aging is driven by external variables. variables that we largely control.
The environmental catalysts are huge here. The text highlights ultraviolet radiation, specifically the deep UV penetration between 10 a.m. and 4 p.m., as a massive generator of oxidative stress in skin cells.
Yeah, and urban pollution introduces highly reactive particulates directly into our respiratory system.
And smoking. Smoking is essentially the act of directly infusing lung tissue with free radicals.
Yeah, it's terrible. But the dietary component the author mentions is particularly striking to me. We all understand that diets heavy in tried foods are problematic for, cardiovascular health. But the text explains the underlying aging mechanism.
The high heat, right.
Exactly. The high heat cooking process fundamentally alters the chemical structure of fats, oxidizing them. So when you consume those oxidized lipids, you are ingesting preformed free radical cascade.
You're just introducing molecular rust directly into your digestive system.
Literally eating rust.
But
fortunately, the biological machine has integrated defense systems. We produce endogenous antioxidants, molecules like superoxide dismutase and glutathione.
You can think of them as cellular philanthropists.
I love that term.
Yeah, they possess surplus electrons, and they're capable of just donating them to neutralize free radicals without becoming unstable themselves. They halt the chain reaction.
They satisfy the molecular thief before it can damage vital infrastructure. But, and this is a big but, due to the overwhelming oxidative load of our modern environment, combination of pollution, psychological stress, processed diets.
Our internal production simply cannot keep pace.
It just can't. We're forced to rely heavily on exogenous antioxidants derived from our diet, primarily from plants.
However, the text isolates one specific critical defense mechanism that is frequently misunderstood and widely neglected, and it's not dietary.
Right. It's the biochemical function of sleep, specifically tied to melatonin.
Yeah, melatonin is almost universally marketed and understood merely as a sleep aid, right? Like just a hormone that signals the brain it's time to shut down.
Yeah, you see it on the pharmacy shelf next to chamomile tea.
Exactly. But the author highlights its secondary, arguably more vital role. Melatonin is one of the most potent, wide-reaching antioxidants the human body produces.
It permeates cell membranes and neutralizes highly toxic hydroxyl radicals.
But the critical variable is the production trigger. The pineal gland only synthesizes melatonin in the absence of light. Light exposure, particularly blue light from screens, actively inhibits its production.
Which fundamentally changes how we should view our evening routines. If you're reading on a tablet late into the night or sleeping in a room illuminated by streetlights, you aren't merely disrupting your sleep cycle.
No, you are chemically suppressing your body's primary mechanism for clearing out the day's accumulation of cellular rust.
It's wild to think about it that way. Prioritizing 8 hours of sleep in absolute darkness isn't just about feeling rested. It is a vital, non-negotiable chemical repair protocol.
And this specific intersection of behavior and biology raises a really fascinating question regarding human agency. Like, how much authority do we actually have over the rate of our biological decay?
Right.
The text introduces the historical case study of Linus Pauling to sort of explore this boundary.
Yeah, Pauling is a legendary figure in chemistry. A two-time Nobel laureate who essentially mapped out the nature of the chemical bond.
Right.
And later in his life, he became intensely focused on the chemistry of aging. Based on the mechanics of oxidative stress we just discussed, Pauling hypothesized that massive hyperdoses of ascorbic acid, which is vitamin C, could aggressively combat free radical damage.
He championed orthomolecular medicine, basically ingesting amounts of antioxidants far beyond standard dietary recommendations.
And the results of his approach provide an incredibly interesting data point. Pauling remained highly active and lived to the age of 93, passing away in 1994.
And for context, the average life expectancy for a male of his generation was closer to 70 years. He surpassed the statistical average by over 2 decades.
The author obviously acknowledges that vitamin C is not an immortality elixir. It didn't stop Pauling from eventually dying. But his lifespan powerfully suggests that the biological clock is somewhat malleable.
Exactly. By aggressively neutralizing the molecular rust, he optimized the machine. He proved we aren't completely helpless bystanders to our own aging process.
We can absolutely mitigate the external damage and maximize the efficiency of the biological housing. We can keep the car in the garage, maintain the engine, and prevent premature rusting.
But mitigating chemistry only addresses one vector of aging.
Right.
Because even in a theoretically perfect environment with zero oxidative stress, the biological machine is still governed by internal limits. To understand the true boundaries of human longevity, we have to transition from the chemical environment to the genetic command center.
Yeah, we have to zoom out slightly to understand the sheer logistical nightmare of maintaining a human body. We are an aggregate of roughly 10 trillion individual cells.
That number is just hard to fathom.
It really is. And the primary mandate of the vast majority of those cells is to maintain their structural role and eventually to replicate themselves to replace dying cells.
And the instruction manual for that replication is, of course, the DNA. The human genome contains tens of thousands of genes, which are densely spooled around specialized proteins called histones to form our chromosomes.
Right. And when a cell prepares to divide, it has to unspool that massive genetic library and duplicate billions of base pairs perfectly.
Which is impossible, right? Biological copying is inherently flawed.
Exactly. Over the span of trillions of cellular divisions, the replication machinery just makes errors. Environmental radiation causes breaks in the DNA strands. These are genetic mutations, and they just accumulate.
Now, the cell possesses sophisticated DNA damage response pathways, enzymes that constantly patrol the genome, identifying errors and repairing them. But the text draws our attention to the thermodynamic reality of this process.
Repair is extremely expensive.
Extremely. This is where the biology gets incredibly intricate. The specific enzymes responsible for fixing these DNA strand breaks, like the PRP enzymes, they require massive amounts of a molecule called NAD+ to function.
And NAD+ is an active derivative of vitamin B3, right?
Yes. And as we age and the sheer volume of DNA damage increases, our cells burn through their NAD+ reserves, attempting to keep the genome stable.
And the depletion of NAD+ triggers a systemic crisis. Because NAD+ is not just a repair molecule. It is an absolute requisite for the mitochondria to produce ATP, which is the foundational energy currency of all cellular function.
So if a cell exhausts its NAD+ on repairing DNA, it literally starves itself of energy.
Exactly. And when the damage exceeds the capacity for repair and the energy reserves collapse, the cell enacts a drastic programmed protocol known as apoptosis.
Which is essentially cellular suicide. The cell determines that its mutated state poses a threat to the surrounding tissue, perhaps a risk of turning cancerous, so it systematically dismantles itself for the greater good of the organism.
And in a youthful system, apoptotic cells are rapidly cleared away and replaced by robust new cells.
Right.
However, as the systemic damage accumulates over decades, the rate of apoptosis begins to outpace the rate of cellular replacement.
That's the turning point.
It is. This is the precise mechanical reason why human organs gradually lose their functional capacity. The physical architecture of the tissue is quite literally thinning out because the cells cannot replace themselves fast enough to cover the losses.
Which introduces one of the most profound biological paradoxes discussed in the text. It involves a specific protein known as P53.
Oh man, P53 is wild.
It is. P53 is a transcription factor that is widely celebrated in molecular biology. It is frequently designated as the guardian of the genome.
Because its primary function is tumor suppression. When a cell sustains severe DNA damage that could potentially mutate into a malignant cancer, P53 acts as the ultimate emergency brake.
It halts the cell cycle.
Yeah, it prevents the mutated cell from dividing, and if the damage is unrepairable, P53 forcefully initiates apoptosis. It's our frontline defense against oncogenesis.
And it is remarkably effective at preventing tumors. But the author illuminates the evolutionary trade-off here. It's a concept known as antagonistic pleiotropy.
That sounds complicated, but it's actually conceptually simple, right?
Exactly. It just means the very mechanism that ensures our survival in our reproductive years becomes the engine of our degradation in later life.
Because P53 is so aggressive in its mandate to eradicate potentially cancerous cells, its chronic activation over a lifetime systematically dismantles our healthy tissue architecture.
Wow.
Every time P53 forces a cell into apoptosis to prevent a tumor, it leaves a microscopic void in the tissue. So over decades of constant vigilance, the sheer volume of cells eradicated by P53 contributes massively to the atrophy of our organs.
So the guardian of the genome ends up degrading the biological housing just to save it from catching fire.
Exactly. It is a devastating biological compromise. What protects us actively destroys us.
But even beyond the damage and the repair mechanisms, the text points out that there is a fundamental hardwired expiration date built into the replication process itself.
This brings us to the most heavily researched mechanism of biological aging. The telomeres. The source material uses this brilliant, highly accessible analogy to explain their function. It compares telomeres to the aglets on a pair of shoelaces.
Those little plastic tubes at the very ends.
Yes, the aglets. The plastic tip doesn't contain any of the structural threading of the shoelace itself. It serves no functional purpose in actually tying the shoe. Its sole existence is to protect the structural integrity of the lace from fraying and unraveling.
And that is precisely how telomeres operate. They are repetitive sequences of non-coding DNA positioned at the extreme termini of our chromosomes.
Right.
And they exist to solve a critical flaw in how our genetic code is copied, which is known as the end replication problem. You see, when the enzyme DNA polymerase moves along the strand to copy it during cell division, it physically requires a small segment of DNA to bind to in order to start the process.
Needs a landing pad.
Exactly. And because of this mechanical requirement, it can never replicate the absolute final sequence of the DNA strand.
It's a sheer mechanical limitation. Every single time a cell divides, the newly copied chromosome is slightly shorter than the original.
Just a little bit.
Yeah. And if our vital genetic instructions, the codes for making proteins and maintaining life, if they were located at the very edge of the chromosome, we would begin losing essential biological information the very first time our cells replicated.
It would be an immediate catastrophic system failure.
So telomeres act as the expendable buffer. Because the ends of the chromosomes are capped with these long, repetitive telomeric sequences, the cellular machinery simply fails to copy a tiny segment of the telomere instead of the vital genome.
The vital DNA remains completely intact.
But the protective buffer is finite. The plastic tip of the shoelace gets progressively shorter with every subsequent division.
Over decades, after trillions of divisions across the body, the telomeres eventually wear down to a critical threshold. The buffer is just gone, and the actual genetic code is suddenly exposed and vulnerable.
And the cellular machinery is highly sensitive to this state. When a telomere becomes critically short, the cell interprets it as a severe DNA double-strand break.
It panics. Total panic. It triggers an immediate, massive DNA damage response. To prevent the exposed chromosome from fusing with other chromosomes and causing massive genetic instability, the cell permanently locks its cycle. It enters a state of irreversible growth arrest known as cellular senescence. And this hard boundary, this absolute limit on how many times a normal human cell can divide before its telomeres run out and it just freezes, is known in biology as the Hayflick limit.
Yes.
For human biology, that limit dictates that a cell can only replicate roughly 40 to 60 times. Once it hits that number, the biological clock simply runs out.
And senescent cells do not simply die and quietly disappear. They remain metabolically active, but their function changes drastically. They begin secreting a toxic cocktail of inflammatory cytokines and enzymes that degrade surrounding healthy tissue.
Oh, man.
Yeah, it's known as the senescence-associated secretory phenotype, or SASP. It is the primary driver of the chronic, low-grade inflammation that characterizes aging, which is often referred to as inflammaging.
So the shortened telomeres not only stop cellular renewal, they actively poison the local environment.
It paints a very grim picture of an inescapable programmed decline. But the text introduces a fascinating countermeasure, a specialized enzyme called telomerase.
Ah, telomerase. This is the magic bullet, right? It's a reverse transcriptase enzyme that possesses the unique ability to synthesize new telomeric DNA.
So it literally rebuilds the telomere after the cell divides.
Exactly. It replaces the worn-out plastic on the tip of the shoelace.
So if a cell has active telomerase, it never hits the Hayflick limit. It can divide continuously without ever triggering cellular senescence. It is, from a purely biological standpoint, the mechanism for cellular immortality. And we actually have this enzyme in our bodies.
We do, but its expression is tightly regulated. In a healthy adult, telomerase is largely suppressed in our somatic cells, which are the cells that make up our organs and tissues. It remains active primarily in our stem cell populations, which require the ability to divide numerous times to regenerate damaged tissue. However, there is one other specific cellular population where telomerase expression is notoriously rampant.
Malignant cancer cells.
That is the dark side of cellular immortality. The vast majority of human cancers, like over 85%, achieve their deadly, uncontrollable growth specifically by hijacking the genetic controls and reactivating the telomerase enzyme.
Because they can continually rebuild their telomeres, cancer cells evade the biological expiration date. They divide indefinitely, eventually overwhelming the organism. The text highlights a really profound laboratory experiment that perfectly illustrates this double-edged sword. Researchers extracted normal human somatic cells, just regular skin cells, and genetically engineered them to continuously express telomerase in a petri dish.
And the outcome was a striking validation of the telomere hypothesis.
Totally. The unmodified control cells divided normally until they hit the Hayflick limit at around 60 divisions, and then they stopped and aged. But the cells with artificially activated telomerase blew right past the limit.
Wow.
They divided over 300 times, with no signs of senescence, no genomic instability, and no loss of youthful function. They simply kept going.
Which naturally leads anyone to ask why we aren't pursuing systemic telomerase activation as a therapeutic intervention for aging.
Right, just turn it on in everyone.
But the limitation is the oncogenic catch we just detailed. The biological barrier is incredibly narrow, systemically activating an enzyme that grants infinite replicative potential in a body comprised of 10 trillion cells, many of which already harbor latent DNA mutations.
It's a recipe for aggressive system-wide tumor formation.
Exactly. Safely decoupling telomerase activation from cancer proliferation remains the absolute frontier, the holy grail of modern gerontology. The biological machine heavily guards the mechanism of eternal youth.
And as we age with our telomerase suppressed, we experience the downstream effects. The text connects this specific biological limit to the concept of stem cell exhaustion, because even the stem cells, which have access to limited telomerase activity, eventually hit their replicative boundaries.
And stem cell exhaustion is a critical failure point in the aging phenotype. The text points to the hematopoietic stem cells located in our bone marrow as a primary example.
Those are crucial.
Yeah, these cells are responsible for generating the entire spectrum of our blood and immune cells.
As the decades pass, those specific stem cells accumulate DNA damage, their telomeres shorten despite the telomerase, and their regenerative capacity plummets. They simply cannot produce the necessary volume of naive T cells and robust immune components.
Which is why the elderly experience such profound vulnerability to novel infections and a stark decrease in vaccine efficacy. The internal factory responsible for synthesizing the immune system is fundamentally shutting down.
All of these mechanisms, the oxidative rusting, the depletion of NAD plus BIOR, the antagonistic behavior of P53, the Hayflick limit, and stem cell exhaustion, they all demonstrate that the physical housing is inextricably programmed to wind down.
So this biological reality forces a necessary pivot back to the philosophical core of the text. If our expiration date is so rigidly encoded into our molecular biology, are we essentially biological automatons ticking down to a preordained moment of failure?
Right.
The text uses this intersection to directly confront a pervasive theological and cultural fatalism.
It is a mindset common to so many cultures and even various religious traditions.
Yeah.
The belief is often summarized by the phrase, "You only die when your time comes."
Yeah, I've heard that so many times.
We all have. It suggests a rigid, inescapable determinism regarding the end of life.
And the author vigorously dismantles this fatalistic perspective. He argues that interpreting life as a fixed track is not only a misreading of the biological reality we just discussed, but it is fundamentally a theological error. It strips humanity of agency.
Because the fatalistic argument generally relies on a specific interpretation of divine omniscience, right? The logic dictates that if a creator possesses perfect foreknowledge of all events, including the exact date and mechanism of an individual's death, then that future event is immutable. It is fixed and obligatory.
But the text elegantly separates those two concepts. It argues that perfect foreknowledge does not equate to active causation.
Exactly.
Knowing the outcome of a scenario does not mean you force the actors to make their choices. If God's omniscience completely nullified human free will, the concept of moral and physical responsibility would just disintegrate. And the text uses a highly practical, everyday analogy to expose the flaw in fatalistic thinking.
I loved this part. If a person genuinely believes that the specific hour of their death was predetermined before they were born, and absolutely nothing can alter that timeline, it incentivizes extreme negligence.
Right. Why look both ways before stepping into a busy intersection?
Why concern yourself with mitigating the oxidative stress from smoking or a poor diet? If the outcome is locked, the inputs are irrelevant.
Strict determinism breeds apathy. But the author counters this by pointing out that the biblical narrative constantly and aggressively demands the exact opposite. The theology presented in the text is deeply rooted in stewardship. It commands active participation in the preservation of the biological machine.
The text highlights specific directives, like 1 Timothy 4.16, which explicitly commands the individual to take care of yourself. It is not a passive suggestion. It is an active mandate to exert agency over one's physical and spiritual state.
Furthermore, the text emphasizes that biblical longevity is frequently conditional. It's tied to tangible human behaviors. The author references the fifth commandment, the mandate to honor one's father and mother. It's the first commandment that includes a specific biological promise so that your days may be prolonged.
Which means the theological framework presented here perfectly aligns with the biological reality. We possess genuine agency. We cannot rewrite the fundamental laws of cellular biology. We can't permanently circumvent the Hayflick limit or magically synthesize infinite NAD++.
But our daily granular choices directly dictate the rate at which we approach those limits. We control the variables that accelerate or decelerate the oxidative rusting.
But to ensure a comprehensive theological analysis, the text addresses the most common counterargument to this idea of physical stewardship. It points to the words of Jesus in Matthew 6:27, where he asks, "Who of you by worrying can add a single hour to his life?"
Oh, yeah. On the surface, that sounds like a definitive statement endorsing biological determinism.
It really does, and it is frequently cited as such, but the author provides vital exegetical context here. That specific passage is situated within a broader discourse concerning material anxiety. The Greek word used for worrying, merimno, implies a mind that is fractured or divided by anxious care.
So Jesus is not delivering a treatise on genetic determinism or the immutability of the human lifespan.
Exactly. He is addressing the psychological state of the listener.
Precisely. The mandate is to combat the suffocating effects of anxiety and to cultivate a foundational trust in the sustainer of life. It's a psychological intervention.
Using that verse as a theological justification to abandon basic prudence, to ignore physical health, or to dismiss the biological mechanisms of aging is a gross misapplication of the text.
There's a profound distinction between the responsible stewardship of the biological tabernacle and an obsessive, fearful fixation on preventing its eventual collapse.
That distinction is incredibly clarifying. We are entirely responsible for the upkeep of the machine, but we must simultaneously accept its temporal nature. As the text moves toward its conclusion, it explores how we should approach that final boundary.
Even without a specific predetermined expiration date, the author suggests that individuals who live in deep alignment with their purpose often develop a profound spiritual sensitivity to their impending transition.
Yeah, the text examines the historical accounts of significant biblical figures to illustrate this phenomenon. It paints a picture of individuals approaching the failure of their biological machinery, not with terror, but with a quiet, observant awareness.
The imagery is really powerful. The text points to Moses, standing on the elevated ridges of Mount Nebo, looking out over the expanse of the Promised Land that he knew he would not physically enter.
Right.
And the Apostle Paul, confined in the damp, freezing conditions of a Roman prison, writing with absolute clarity to Timothy that the time of his departure was imminent.
And what unites these disparate accounts is the stark absence of panic or resistance. In those specific moments, they did not view their impending death as a violent intruder.
Why the shift in perspective?
Because they were looking backward over a fully realized narrative. They had executed their specific callings, they had stewarded their physical and spiritual resources, and they possessed no lingering moral debts or unfinished mandates.
So the biological clock, the telomeres, the stem cells, was winding down in perfect synchronization with the completion of their spiritual assignment.
Exactly. Which culminates in one of the most intellectually stimulating theological provocations in the entire source material. It forces the reader to reconsider the fundamental nature of the physical ecosystem described in Genesis.
Okay, let's get into this.
We established early on that the text views death as an intruder initiated by human rebellion, but the author demands we ask a more precise question. What specific category of death was introduced in Eden?
Because when the initial warning was given that consuming the fruit would result in death on that very day, the physical outcome did not match the immediate timeline.
Right. The humans involved did not experience sudden, catastrophic biological failure. They continued to live, metabolize, and age for centuries.
So the author deduces that the immediate catastrophic death introduced in Eden was exclusively spiritual. It was the severing of the communion between the finite human spirit and the infinite creator.
The text then unpacks the biological reality of the Edenic environment. Even an ecosystem characterized as perfect is still governed by thermodynamics. Energy must transfer. Biomass must cycle. The physical human body was constructed from the elements of that material world.
And the author points to a singular, vital detail included in the Genesis narrative that shifts the entire paradigm.
The presence of the tree of life, situated in the center of the garden.
This detail changes everything. If the biological housing, the human body, was inherently genetically immortal, there would be absolutely no functional requirement for a tree of life.
It would be a totally redundant feature in the ecosystem.
The inclusion of the tree strongly implies that the human biological machine, despite its flawless initial design, was naturally subject to entropy. It was governed by the laws of physics and the mechanical limitations of cellular division.
Wow.
To maintain physical immortality, humanity required access to an external sustaining mechanism.
So the biological machine required a continuous, supernatural maintenance protocol. We can conceptualize the tree of life as providing a mechanism for perfect DNA repair, maybe acting as an ultimate epigenetic reset or a flawless telomerase activator.
Regardless of the exact mechanism, the physical body was fundamentally dependent on an external source to prevent the molecular rust and the shortening of the telomeres.
Consequently, when humanity rebelled and was exiled from that specific environment, the tragedy was twofold. They suffered the immediate spiritual severance, but they're also physically cut off from the external maintenance mechanism.
Right. Without access to the tree, the inherent natural biological processes just took over. The molecular rust began to accumulate unchecked. The plastic tips on the shoelaces began to wear down.
Aging was not necessarily a newly invented punishment. It was the natural biological consequence of being separated from the source of continuous renewal.
That interpretation fundamentally reorients our understanding of the end of life. It perfectly synthesizes the biology and the theology. It delineates the two types of physical death.
A premature death, driven by violence, preventable disease, or an accelerated rusting process due to poor stewardship, that remains the tragic intruder. It is a violation of the intended lifespan.
But a death that occurs in a blessed old age, when the individual has lived fully, stewarded the biological housing prudently, and the Hayflick limit is reached naturally, is no longer categorized as a tragedy.
It is transformed into a divine portal. The text observes that the pervasive human fear of death is intrinsically linked to the spiritual separation that occurred in Eden. It's a fear of the void. But when that spiritual communion is restored, the fear is structurally replaced by hope.
The physical degradation is recognized merely as the dismantling of the temporary tabernacle, while the immortality software, the human essence, actually anticipates its transition.
We have covered immense ground today. Navigating from the atomic behavior of free radicals to the sweeping theological narratives of Genesis.
It's a lot to process.
It is. We've explored the profound friction of human existence. We are spiritual entities, programmed with a desire for infinite continuity, yet we are tasked with operating a biological machine that is meticulously designed to eventually wind down.
We're caught in the space between our eternal consciousness and the finite reality of our telomeres.
Exactly. Our responsibility is clear. We must aggressively steward the physical housing. We have to combat the oxidative rust through prudent daily choices, from optimizing our sleep in the dark to managing our environment. We must respect the biological parameters while acknowledging that our ultimate trajectory extends far beyond the Hayflick limit. I'll turn it over to you to close us out.
Well, the text leaves us with a fascinating perspective on the tree of life as a necessary external mechanism for cellular maintenance in Eden. I want to leave you with a thought regarding our current scientific trajectory. Consider the billions of dollars currently being poured into genetic reprogramming, into the desperate pursuit of safely activating telomerase without triggering oncogenesis, and into the emerging science of cellular rejuvenation.
It's a massive industry.
Huge. If the theological premise of this text holds true, that we were originally sustained by an external biological mechanism that we subsequently lost, it raises a profound question. Is the entirety of our modern, hyper-advanced pursuit of extreme longevity and genetic manipulation essentially humanity's subconscious, desperate attempt to synthetically recreate the tree of life? Are our greatest scientific minds simply trying to hack their way back into the ecosystem of Eden?
That is a phenomenal question to sit with as you consider the passage of time. Because the next time you look in the mirror and realize that time is not merely a neutral clock on the wall, you will understand exactly what is happening beneath the surface. You will comprehend the complex interplay of the cellular rest, the genetic limitations, and the profound spiritual machinery driving you forward. Until next time.